Hello, my name is Mark Fauzi and I'm with Sensar RPG. Today I'm going to talk to you about an incredibly powerful way of remixing REST APIs in a declarative manner that helps us remove the need for doing imperative data aggregation, data derivation, and data shaping, which usually happens in the mid-tier and or in the client. Doing it this way helps us get rid of all of that incidental complexity by going from imperative techniques to declarative techniques using GraphQL. The two very helpful pieces of technologies that I found recently is GRAMPS and GraphQL bindings and related tools and modules. So GRAMPS is basically a way to allow us to build, publish, share composable data sources that can be used together to build GraphQL servers. Those data sources could be REST APIs, for example. GraphQL bindings and yoga and related tools and modules by GraphQL team allow us to implement schema delegation, which is to basically integrate GraphQL schemas into one. And it also takes it to the next level by allowing static type checking to happen. So instead of using GraphQL queries and mutations as strings, they become basically statically typed functions. And if you're using a language like TypeScript, which we're using in this demo, um, you're able to get IDE support for type checks on your GraphQL types and queries and mutations, and also compile time type checking. So it's very powerful combination. The goal here really is described in these bullets. First, we want to be able to convert the REST APIs that we have into GraphQL data sources that can be shared amongst our internal teams as well as with external teams at customer teams. We want to enable the automatic merging of such sources into one GraphQL schema that can be accessed by internal or external teams to build apps in an agile manner that uses GraphQL's declarative nature. The idea is to to use GraphQL to remove the need for imperative data aggregation, derivation, and shaping. This means we can have a pure UI that is basically just a thin I/O layer with queries and mutation, and a pure projection of app state on the app state on the server. Um, so that's enabled by GraphQL itself. What we're talking about today is more about how we take the REST APIs, convert them into GraphQL data sources, merge their schemas, and be able to uh, remix them into a new GraphQL schema without having a separate GraphQL server for each data source. So this is very efficient, a very declarative way of remixing REST APIs so that the front-end developers no longer have to rely on the back-end developers to make tweaks um, to existing REST APIs or to build new REST APIs out of existing REST APIs. No longer does the front-end developer have to wait on the back-end developer or the back-end team, which may be in a separate team, or a separate company altogether, in order for them to develop functionality. And no longer do they need to, have it aggregate multiple APIs and transform them and shape them and maybe derive new data from the data that comes through the APIs, and do all that in the UI or in the mid-tier in an imperative fashion. No longer do they have to do that. They will be able to do all of that declaratively, therefore giving the front-end developers the ability to run fast and have less errors in the process, and be able to respond to changing business requirements in an agile manner. That is really the overall benefit of all of this. So we will go to the repo here. We put together a repo. Feel free to start it. It's a great API matcher at username ittybittyart, and list of the contributors. So, for example, we took the XKCD API, which is the comics, popular web comics. This is what we get from the API. We construct a GraphQL schema that represents that, and then we write the associated resolvers. We take another API, look at its different outputs, and construct the corresponding GraphQL schema and the associated resolvers. And then we take a third API. In this case, it's a made-up API. It doesn't actually go out to get any data. It's all canned data, but it demonstrates a very powerful concept of having variability in the API output. For example, if the user is authenticated, they may get green apples. If they're not authenticated, they may get cherries. So that it explains how to use the powerful union feature in GraphQL, and how to be able to dictate from the schema that merges all these APIs, whether you want to get green apples, cherries, or a mixed basket of both. So it works for APIs where the output is predictable, as well as for APIs where the output could be varied in terms of its structure. So this is an example of the automatically generated merged internal schema. It doesn't actually involve the developer having to do that manually. It just automatically generates it in the build process. And this is the example of the actual application schema that's going to be associated with the GraphQL server. That is basically a remixing of types. So this is an actual import syntax where we're importing all these different types from the different data sources, and we're remixing them here to generate new types, new queries. In this case, in the next POC, will show the mutations, and we'll explain the use case for remixed mutations. And so from there, we go to building the resolvers for the remixed APIs, remixed schema, and we display some advanced techniques here too that you could read about in the repo. And the final effect of it is that we can take the XKCD API, we can take the numbers trivia API, and our mock API and mix them together, basically creating a new arbitrary data structure that normally would entail doing a lot of imperative aggregation and derivation and shaping logic in the mid-tier or in the client. And definitely we don't want the stuff to be in our client. That's the base line for success, not to bring in all this incidental complexity into the client. So GraphQL already helps us with that. This is mostly about another layer of flexibility where you don't simply consume GraphQL from a single API, REST API. You consume it from multiple such APIs and be able to remix those APIs so that it eliminates the need completely for doing anything imperatively. Everything becomes declarative, and all that logic gets out of the client and out of basically out of our code base. And all we need to do is what I described earlier, the declarative definitions in the schema, the associated type resolvers, and just running with using this framework to achieve all of that. So the end goal is that we remixed comics with trivia. We remixed it with we mixed trivia and fruit, and we have we're able to at runtime determine if we get this type of output from this API, then this is what we want to get back. If we get this other output, this is what we get back. So it's an extremely comprehensive and powerful way to take existing REST APIs and declaratively merge them together and then remix all the types that are in your data and that are exposed by the REST APIs. So basically, you're decomposing your REST APIs and recomposing them, and that's extremely powerful. And it allows you to get rid of a ton of imperative code and make your development go much faster, and also reduce the amount of errors and bugs and all of that. So I hope this has been useful. Please check out the repo. Again, the repo URL is, I don't think you can see it here. So let's, here. So that's the repo URL, and feel free to check it out. Thank you.